Imagine a world where drones fly autonomously over vast fields, capturing data that could dramatically increase crop yields and revolutionize agriculture. This isn't science fiction. It's happening right now with AI-powered crop monitoring drones. At the heart of these drones is artificial intelligence, a technology that enables machines to mimic human intelligence. In crop monitoring, AI processes data from sensors and cameras attached to drones. These sensors capture high-resolution images and data about the crops below. AI analyzes this information to identify patterns and anomalies that human eyes might miss. For example, it can detect signs of disease, pests, or nutrient deficiencies in plants, often before they are visible to the naked eye. This early detection allows farmers to address issues promptly, potentially saving entire harvests. Consider a farm in the Midwest United States, where a farmer uses AI-powered drones to monitor cornfields. Traditionally, farmers would walk through their fields, inspecting crops manually. This labor-intensive process is not only time-consuming, but prone to human error. With drones, the farmer can scan hundreds of acres in a fraction of the time. The AI processes the images captured by the drones to assess plant health, measure growth stages, and even predict yields. This data-driven approach allows the farmer to make informed decisions about irrigation, fertilization, and pest control, optimizing resources and reducing waste. In another example, vineyards in France have adopted this technology to maintain the health of their grapevines. Drones equipped with AI analyze the color and texture of leaves, indicators of a vine's health. By identifying stress factors early, vineyard managers can take corrective action, ensuring the quality and quantity of their grape harvests. The AI system can even recommend specific interventions, such as adjusting water levels or applying targeted treatments, enhancing the precision of vineyard management. The implications of AI in crop monitoring are vast. In regions prone to drought, AI can help farmers better manage water resources by providing precise data on soil moisture levels. This can lead to more sustainable farming practices, conserving water and reducing environmental impact. Moreover, AI can contribute to food security by increasing agricultural efficiency, a crucial factor as the global population continues to grow. However, the integration of AI in agriculture is not without challenges. Concerns about data privacy and security arise when drones capture detailed images of private lands. Additionally, the initial investment in AI technology can be prohibitive for small-scale farmers, potentially widening the gap between large agribusinesses and family farms. There are also risks associated with over-reliance on technology, where farmers might neglect traditional knowledge and intuition. Looking to the future, AI-driven crop monitoring could become an integral part of a more interconnected agricultural system. With advancements in machine learning and data analytics, these drones could eventually self-optimize, learning from past data to improve their accuracy and recommendations. This evolution could facilitate a new era in agriculture, one where technology and nature work in harmony to feed the world more efficiently and sustainably. In conclusion, AI and crop monitoring drones represents a significant leap forward for agriculture. It holds the promise of higher yields, better resource management, and enhanced sustainability. However, it also poses new challenges that require careful consideration. As we continue to explore this technology, balancing innovation with ethical responsibility will be key to unlocking its full potential.